As we go into our unit on periodic trends, the family of elements lab that we do is a very good demonstration of where things are in the periodic table can give you a good idea of how they're going to react. And we're going to study 4 solutions, 4 different elements, and how they react with a fifth substance, our silver nitrate, in this lab. There are half sheets that we got when we did this lab in class. If you were absent, or even if you were in class and you got this, glue this into your spiral. If you want to fold the top half and flip this page over and write everything on the back, you can. Or if you want to glue a frame and then answer your questions on a separate sheet of paper, you can do that as well. I'm going to walk you through what we would have seen, or what we did see when we did the lab in class. If you are absent, please make sure that you are still reading everything that we did, so that as you look at the results that we'll be talking about here in a few moments, you'll understand what led up to that. So looking at the materials that we're using, we had a well plate and solutions of chlorine, bromine, iodine, sulfur, and silver nitrate. Right, this is where memorizing our symbols is starting again to come in handy. So these are the materials that we had at our stations. This is our well plate. Right here, it is a plate with wells in it that we could put samples into. These are the solutions of our materials. This is silver nitrate. This, in this different colored bottle, is what will be reacted with everything else. We see potassium sulfide, potassium bromide, potassium iodide, potassium chloride. These are solutions of these elements. And so since it's potassium in every one, potassium is not the thing that we're going to be testing. In this experiment, we're keeping consistent and constant everything except the one item that we are testing, which is the different elements. What we do with these materials is in our procedure, place 5 drops of the solution chlorine in well number 1, 5 drops of bromine in well number 2, and then we had the other substances that we placed. So we need to be able to recognize that our sulfide or our sulfur was hidden here in our potassium sulfide. Bromine was in the bromide. Iodine was in the iodide, and chlorine was in the chloride. So these are things that as we progress in the unit and progress in the semester, you're actually going to learn how to read these and write their formulas. And again, having memorized the symbols is going to help you greatly in that. So this is well number 1, this is well number 2, number 3, number 4, and then we, according to our instructions, after we have begun reacting them, we wait 5 minutes, write electron configurations while you are waiting. Okay, so this is something I'm going to go ahead and review with you real quickly. I'm not going to show you the electron configurations for the elements in the lab itself, because that's part of what you have to do. But I will go over some examples of other elements that are not in the lab. Maybe nitrogen. Let's start with nitrogen. So nitrogen, in order to write down the electron configuration for it, we need to look at its atomic number. Its atomic number, I'll put up here, is 7. It's the whole number on the periodic table. So that means that it has 7 protons and 7 electrons. It is in the second energy level, which is another clue. It tells me that there's going to be 2 energy levels. And if I was going to draw a Bohr model for this, I would draw 1, 2 energy levels. It's understood that we do have the nucleus down there in the center, but it's teeny, teeny, tiny. We can't really see it. The 7 means that we have 7 electrons to place in that area. We have 2 2 that we can put in the first level. On the second energy level, we can put a few more. If we look for where nitrogen is, it's in the same period as lithium. It's the 1, 2, 3, 4, 5th element. So that helps me remember that there's going to be 5 electrons on the outer shell. It's also in group 5A, so that's another shortcut hint to tell me there are 5 electrons in the outer shell. So I can start with 1, 2, 3, 4, 5, and there we go. We'll stop there. There's 5. So if I was to count the number of electrons that I have, then I will have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. There we go. I lost count. 7 electrons. When we write the electron configuration, which is really what I'm asking you for in the lab, you always start from the beginning with a 1, first energy level. S-shaped orbitals are the most simple, those spherical shaped orbitals, so we're going to fill those in first. We have 1, 2 places for electrons in our first energy level, so we'll put that 2. But we're not there yet. Nitrogen is in the second energy level, so we have to show that we've gone to the second energy level with the 2. Looking at the periodic table, first I have to fill in my spherical orbitals, and this whole S block here reminds me of that. So 2s1, 2s2, the spherical shaped orbitals, we're going to fill that in first. But we're not there yet because nitrogen is here. We are still in the second energy level, so we're going to write a 2 for second energy level, but we're now in the P block, or those peanut-shaped orbitals, those that go like that. So now I have to denote that by writing a letter P, and I'm in the 1, 2, 3rd spot, so that's 2p3. That's your electron configuration, really. Now your questions are going to ask you to identify the outer energy level for each of the elements that you're going to be studying, which are these guys here. So you look for the largest number that we have, and that is 2, which means our outer energy level was the second energy level. And if we count the electrons that are just in that energy level, 2 plus 3 is 5. 1, 2, 3, 4, 5. Our 5 valence electrons. Okay, so let's move on to something a little bit more complicated, because you are going to have more complicated electron configurations in the lab. So let's choose arsenic, just because arsenic's fun. I'm going to start off the way I always do. Start from the beginning, number 1. Fill in that first energy level. Right, I have 2 spaces there, so start simply with the S, spherical, 1s2. Then we go to the second energy level. It's not in the S-shaped orbitals, so those are filled. 2s2. I keep on going. It is not here, so I have to fill in each of these 6 spaces. It is the P-shaped orbital, so it's 2p6. But I'm not there yet, so let's go down now to the third energy level. I have to show that by writing the 3. Fill in the S-shaped orbitals. We're not there yet. 1, 2, 3, 4, 5, 6. Still not there yet. So fill in 3p6. Down to the fourth energy level. 4. Fill in that S energy level. 4s2. All right, so here's where things start getting a little complicated for some of us. So this drop-down portion of the periodic table here, these are extra electrons that are still being added to the atom. But with all of these electrons here, things are getting a little bit crowded. And on the outer energy level, we can only ever have the numbers that are associated with the A's there. So what happens as we start adding these extra electrons is they drop down, just like this part of the periodic table here drops down. We're going to drop down to the third energy level, and we're going to fill in that block. So this is the D block that we've talked about before, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places for electrons there. So we fill that in with a 3d10. But we're not there yet. We have 1, 2, 3 more spaces to go for arsenic. When we come back to this part, to the P block, we're going back to the previous energy level, which was the 4s, where we were at. We dropped down for the 3, but now that we're back to the P level, we're in still the 4th energy level. So we're going to go back to 4. We're in the P block, and arsenic is the 3rd element in the P block. So that becomes your electron configuration. We have to identify what the outer energy level is, and so the highest number of levels is the 4s, the 4th energy level. So I'm going to box in that 4th energy level, and if I add up the electrons, 2 here, 3 here, that gives me 5. So if I look back to the periodic table, arsenic here with its 33 electrons, and if I counted all of these I would end up with the 33 electrons, has only 5 valence electrons. And it's in group 5a, so that makes sense. Just like nitrogen, the element that we did before. They are both in the same group. They both have 5 valence electrons, so they will behave chemically very similarly. The last part of the lab that I want to show you is our results. And so here I have lined up the elements in the solutions. Oh, let's undo that. I'm trying to look for a pointer. There we go. So I ordered them. Chlorine was your first element, bromine, iodine, and then sulfur was the last one. And so these are the colors here. These are the overall reactions with the silver nitrate. So if you were not in lab with us, if you were absent, you can use this right here. You do still need to make your own data table. But once you do that, those are the observations that you need to put in. And then answer the rest of those questions. Write makeup. If you were absent, make sure that you write makeup on the top of your lab sheet so that when I grade it, I will know why it may or may not be done at the same time as everyone else's that was in class. And that's it. That is the Family of Elements lab.